normal reaction. The normal reaction, which is equal to how much now? M into G. So when a body or a person moving in a lift, the weight of a body, may not be equal to the true weight of a body when he is inside the lift. So that extra weight or maybe less weight, that is called as a apparent weight. So actual weight of a body is how much now? Always this mg. But when the person is inside the lift, if the lift is moving up or down, the weight of a person may not be exactly mg. It may be up or more or less. Okay. So that weight is called as a apparent weight. That weight is called it as a apparent weight. Understood what I am saying? Now, when the lift is at rest, what happens now? Tell me now. If the lift is at rest, apparent weight equal to true weight only. Apparent weight is equal to true weight only. So that is nothing but what we can say now here in this case. What is the weight of a person? You tell me now. In this case, apparent weight. Apparent weight. How much you tell me? Which will be equal to mg only. Yes, take down. So take the case 1. The lift is at rest, right? Now let's see this thing here. Second case. Now, if the lift is moving up or down with a constant velocity, if the lift is moving up or down with a constant velocity, if it is constant velocity, what is the acceleration? Zero. Zero. Now we'll write the equations here also now. Now we'll write the equation. Tell me now here how the lift is now. Tell me now. Moving the constant velocity. So a person weight of the person which is mg, and the normal reaction is upward direction now. And how the lift is now moving now here? Constant velocity. Constant velocity means acceleration is how much? Constant velocity means acceleration is how much? Zero. So this is a value 0. Now in this case also we'll write the equation. Tell me now. Tell me the equation now. What we can write now? Acceleration, which is equal to what? Tell me now. Net force by total mass. So this should be equal to what? Tell me now. mg minus n by m. So here 0 now. We'll take any direction you will take. Both are equal now. That's why. The lift may up or down now. That's why. So in this case, how much is n you tell me now here? That is mg. Now this is only the apparent weight. In this case, how much is apparent weight of a body? In this case, apparent weight which is equal to true weight. Apparent weight in this case also what you tell me now, true weight of a body, that is mg only. Okay. Now, let us say now here some other case now. If the lift is accelerating upward at the rate of a, that means acceleration of the lift is given as a. So here the lift and which is moving upward directions. Now in this case, you tell me now what happens now. What will the weight now here? You see. Now weight, it basically true weight is mg downward direction, and we have the normal reaction n, and what else now here? Yes, now we have lift is moving upward direction. Now we have acceleration upward direction. Right. So in this case, I will write this acceleration. You tell me now here. So that is n. Yes. So in this case, yes, n minus mg by m na. Right. So that means from this, how much this n value? Tell me now. Yes. So that is mg plus ma. So this is the reaction, normal reaction. So, and this will be the weighing machine will consider this as a weight of a person. So actually this is only the weight of actual weight of a person. But in addition to that, this extra term is also added. So when a person is inside the lift, mg is a weight of a person. But here, if the lift is moving upward direction in addition to the original weight, and this extra term also is added. Now this apparent weight. So this we'll write it as what? Tell me now here. If I take it as mg common. So what I will get to tell me now, this is 1 plus, this is a by g now. 1 plus a by g. So that means n. So this will be mg is called as the actual weight of a person. We are calling it as w. W into 1 plus a by g. Okay. Now the apparent weight. This is the apparent weight. In this case, apparent weight is how much? In this case, apparent weight, how much you tell me now here? W into 1 plus a by g. So that's the reason. So when a person is moving upward direction, what happens now? Weight of a person, true weight is more than the person weight. It will display the more than the actual weight. Okay. Now tell me now here, if the lift is going downwards, what happens? So do that one. If the lift is moving downwards, so in this case, so actual weight is mg. And this is a normal reaction. And the lift is moving downward direction. Now this is a. Tell me now here. Tell me the equation now. What will come? So the acceleration equal to what? Tell me now. Mg minus n by m now. So that's why in this case, n value will come to be how much now? So will come to be mg minus ma. So that means what is this n now? Tell me now. If I have taken mg common here also, then it will come to be what? Tell me now. So this is 1 minus a by g. 1 minus a by g. Now, so this we can write it as what? Tell me now here. W into 1 minus a by g. This is the weight of the person. Now, in this case, apparent weight. How much is the apparent weight? You tell me now. So, this is W into 1 minus A by G. So that means in this case, if the lift is moving downward direction, the person weight is less than the actual weight, true weight. Right. And in general, so look at now this and this equation, I will little modify this thing as this is m into, we write it as what I know, G plus A na here. Here this is G plus A. Now this I can treat it as what I know, m into, this will write as G effective. This is the effective G. If the person is moving, so here if the lift is moving upward direction, G effective is how much, you tell me in this case, which is equal to G plus A. Understand what I'm saying? If the lift is moving upward direction, G effective gravity acting on the person is G plus A. Okay. Then next, in this case, you tell me now here. In this case, so what will write now? N is equal to, how will write now here? This is M into, we'll write as G minus A na. So that's, yeah. So in this case, M into what we can say now? G effective G. How much the effective G now here in this case? Which will be equal to G minus A. Right? G effective. So look at now here. If the lift is moving downward direction, effective gravity is G minus A. If it is upward direction, G plus A. Not only for the man, so any type of object, the same thing applicable. Right. Now let's see now here. Fifth case. When the lift is freely falling means what, tell me now here? So, freely falling body. In that case, with what acceleration falling and freely falling body, acceleration is how much? G. For a freely falling body, acceleration is how much? G only, na? So you tell me now from the G effective, we have seen a freely falling. How the lift is moving now, upwards or downwards? Falling means downward. G effective formula. G effective means G minus A na. So that means how much this G effective now in this case, which is equal to 0. That means what the weight of the person, apparent weight is how much, you tell me now. So that's why now this apparent weight, how much this apparent weight is, how much now? So that is M into G effective now. So that's why weight of a person which is equal to 0. Apparent weight. How much? 0 for a freely falling body. So then the person does not feel any weight. Freely. Uh, weightless. So here 0 weight. Uh, right. Done. Next one. Take this thing. Find the tension in the string. Here that is a lift. The lift is moving upward direction with acceleration of 2. Now in this case, so lift is moving upward direction. Then how much the G effective? So upward direction now. So in this case, effective G. So that means G effective, and which will be equal to G plus A na. So how much the G effective now here? G value 10. So 10 plus 2, which will be equal to 12. So from this we can say now tension which will be equal to M into G effective. In place of G effective is same as G. Whenever we add the two quantities, could have same units. Right. So how much the tension now? Tell me now here. M. So 10 into 12, which will be equal to how much now? 120 newtons. Tension they ask in here in this case. That is different. This is different. Normal that will be measured based upon the reaction. Okay, here the tension here. So if the block is going upward direction, so what same concept we are applying here? What is the weight of a body? That is mg, and we have tension T na, and then this is going upward direction. Then write the equation will come the same thing. The concept will have a number of applications. We should not apply only for particular problem. Then next one. A coin is dropped. A coin is dropped at t is equal to 0 from the ceiling of a lift, as shown in the figure. Find the time taken when it hits the floor of the lift. How much time it will take to reach the floor ground? How much the height is? 24 meters. The lift is going upward direction with the acceleration of 2. Now you tell me now here. So it is, since it is dropped. So how much the velocity, initial velocity? Yes, when it is dropped means initial velocity 0 na. Now, and what will be the acceleration now it will experience now? So this is we can say this is G effective will write. How much the G effective you tell me now? How much the G effective now here? The lift is being upward direction na. So that's why G plus A. So this will be how much now G effective, which will be equal to 12. Next. So height is given na, that is a displacement which we have. How much this value? 24 meters. So we'll write the equation now. S is equal to ut plus half at square. Ut plus half at square. Then how much the distance now here? 24. Initial velocity 0 plus what tell me now? Half into A value 12 and T value how much we have to calculate? A value. A means G effective only na. Acceleration means what? G effective. Yeah, G means G effective. Yes, so this is acceleration is G effective. So simplify. So this is 24 and which will be equal to 6 into t square now. Yes, now t square equal to 4 and the t value how much now? 2 seconds. Right? Next one. Completed now? Next concept, impulse. Next one, impulse. Yes, impulse means what? Tell me now. A suddenly, yes, a small force, very high amount of force will happen in the very small interval of time. A large force is applied very small intervals of time, and that is called as an impulse. Like we can say, suddenly accident will happen. Then, so in this case, suddenly, for example, you are simply working, and suddenly your friend will came, with tap on your shoulder. Then you will feel lot of pain. You feel, isn't it? That means that is a yeah. So here, certain force will apply very small interval of time. That is called as an impulse, isn't it? So when a large force act on your body very short interval of time and to produce a finite change in momentum is called as an impulse. Large force will act on a small interval of time that is called as an impulse. Now, impulse will denote with a letter of I. Impulse will denote with a letter of I, that I which will be equal to F into T, force into time, impulse. And so if the force is variable, if it is changing, then we can write it as impulse which will be equal to integral of F into dt. That is, if F is change, if the force is variable quantity, then we have to do integration we need to do. I is equal to integral of F into dt. And this impulse, which is also equal to the change in momentum. This I, which is equal to what element? Change in momentum delta P. And this is equal to what element now? M into delta V. So the impulse, another formula is what element now? M into, we can say this as a final velocity minus initial velocity. If the given velocity is given, we have to use this formula for impulse. If the force given, we use this formula for the impulse. Okay. And some cases they will give the force and time graph they will give. In that cases, that is nothing but area is the impulse will use. They will use some graph they given. So in those cases, impulse which will be equal to what element of area of force time graph, EFT graph we will say, area of force time graph. So if they given the graph like this given, fuse force will act on a body very small time. So in this case, this area is an impulse, the area of this graph. is the impulse. Right. Done. Right. Next one. Newton's third law. Next one. So Newton's third law. Newton's third law is what? Tell me now. Action reaction. Action reaction force. Yes. So action reaction, which is the Newton's third law, and this it gives the law of conservation of linear momentum. It gives the law of conservation of linear momentum. Right. Now let's talk about what is the law of conservation of linear momentum. Right. Now this action reaction pair, you might be heard about this thing here. And so here, if we have taken any body, the body will cause some force on this board. At the same time, this board also will causes the equal amount of force, but it is in opposite directions. Okay. And this action is on one body, a reaction is in other body. Action. So here, action, if I on this body is action, on this body is a reaction. Action reaction will act on two different bodies will act, not on same body always. Action reaction forces are in two different body. That's why these two won't get cancel each other. Right? And so there are so many examples for the third law. Yes, the swimming, so then firing a bullet and a rocket propulsion. All these are examples of a Newton's third law. Yeah. Now let's see the law of conservation of linear momentum. The law of conservation of linear momentum means what? Tell me, if there is no external force acts on a body, the total momentum of a body remains constant. Okay, means as we have seen Newton's law. What is the Newton's law? We have second law we have seen now. F is equal to what? Tell me now. dP by dt. Now you tell me now, if F is 0, what happens? So that means if F is 0, if there is no force acting, that means then this right side term must be also 0 na. That is dP by dt must be equal to 0 na. So differentiation of a quantity 0, that means what? Tell me now. When the derivative of a constant is how much? 0. That means the derivative 0 means I can say that P must be a constant na? Isn't it? P is constant. So from this what we can write now here? So basically, so this means differentiation. This is nothing but what we'll write now. Basically, we'll write now here delta P by delta T, which to write now. This is equal to 0. Delta P means what you tell me now? P2 minus P1. Okay. If final minus initial by delta T, which is equal to 0 now. So that means what we can say now here? P2 minus P1, which will be equal to 0. That means P2 equal to what we can say now? P1. P2 is what? Tell me now. Final momentum. P1 is the initial momentum. From this, what we can say now here? This final momentum equal to initial momentum only na? Final momentum equal to initial momentum. That is the law of conservation of linear momentum. Final momentum equal to initial momentum when there is no external force acts on a body. Final momentum equal to initial momentum. So what we can write now here? Final momentum is a total final momentum. Total final momentum equal to what you tell me now? Total initial momentum. Total final momentum equal to total initial momentum. Final momentum, if I say PF, that should be equal to initial momentum is PI. This is the law of conservation of linear momentum. Yes. Copy now this thing. Done. Right. Now let's see this thing. One of the applications. Let us consider. I have this is one body. Another body. Right. So this body of mass is M1 and this mass is M2. And this is moving with a velocity U1 and this is moving with a velocity U2. And so these two collides. M1 collide the M2. Let us consider. So now after collision, this M1 body will move with some velocity and M2 body will move with some other velocities. Now this is M1 and this is M2. Let us say after collision, velocity of the body is V1. This body velocity is V2. Right. Now we'll apply the law of conservation of linear momentum. Now, yeah, this is before collision. This is before collision. And here this is after collision. And we are considering this both the bodies will move in same direction. It may not be also. If it is opposite direction, we'll get negative sign will come. So what we can write now according to law of conservation of linear momentum. So what we can say now here, total momentum before collision. Total momentum before collision. before collision, and which is equal to what? Tell me now. Total momentum. Total momentum after collision. Total momentum after collision. So we can see now here this momentum of the first body. Momentum of a first body. How much you tell me now before collision? This body m1 into u1 plus, right, simultaneously. So the momentum of the second body, yes, before collision m2 u2, and that should be equal to after collision momentum of a first body m1 v1 plus m2 v2. This is the law of conservation of linear momentum. Done. Right. Yeah. Take this problem. Fast. Now these topics are finished. Problems are there on this momentum and the huh? Next question. Take this one. 10 coins, each of mass m, are placed one over other. Hmm. Hmm. We'll ask the problems are like this only. Find the force exerted by the sixth coin. Yes. On seventh coin from the bottom. Yes. Now they place the coins now one over other. 10 coin they place now. This is 1, 2, 3. This is 4, 5, 6, 7, 8, 9, 10. 10 coin they placed. 10 coin they placed one over other. So if we say this as a, what they asking of here? Force on sixth coin, force exerted by the sixth coin from the bottom on the seventh. From bottom, we need to count it now. So this is 1, 2, 3, 4, 5, 6. Okay, this is sixth. This is the seventh coin. Now they are asking to find what element of force caused by the sixth coin on seventh coin. They are asking to find. So that means here they ask him to find here the force they ask him to find, isn't it? Right. So here the force caused by the this sixth coin pushes the seventh coin upward direction, and at the same time, and the seventh coin pushes this sixth coins to downward direction now. And this is action reaction, equal amount of force but in opposite direction. Now you tell me, now they ask him to find the force caused by the sixth coin on seventh, which will be exactly equal to force caused by the seventh coin on sixth. Yes sir, no. So the upward force and downward forces are equal, action reaction. So tell me now, we need what? Tell me now, force. They ask him to find what element of force on seventh coin, due to sixth coin. Sixth coin, which is also equal to what we can say. What we can say, that is equal to force on sixth coin due to 7, isn't it? Action reaction na? The values are same but opposite directions. These two forces are equal only. So that means how much we can say this force, you tell me now finally. Now the force act on the, which one? Sixth coin we need to find. So that is because of all this weight will causes the force on the sixth coin. Na? So how much the weight of each coin? How much the weight of each coin now here? mg. So how many coins are there above the sixth? 4 coins. So that means how much the force, you tell me now here? So that is force on seventh coin. Now force on sixth coin. Which is equal to how much now? 4 mg. The same amount of force sixth coin will cause on the seventh coin in opposite direction. Okay. Upward force and downward forces are equal. Next one. A gun of mass capital M fires a bullet of mass small m with a velocity u. Find the recoil velocity of the gun. The recoil velocity means when the gun is fired. So the gun will move backside, will move backward. Now that is called as recoil velocity. Right. And bullet will move forward, gun will move backward. Action reaction. So in this case, so here there is no external forces acting. So that's why we can apply the law of conservation of linear momentum. Since there is no external force acts on the system, on the gun and bullet, so we can apply law of conservation of linear momentum. So that is LCLM, law of conservation of linear momentum. Tell me now here, initially gun and bullet both are at rest. Initially gun and initial velocity of the gun is 0, bullet velocity also 0. That means total initial momentum is how much? 0. Gun is at rest, bullet is also at rest. Then, and that is equal to what? Tell me now here. After firing, what happens? You tell me now. So mass of the bullet is m, and the bullet moving with a velocity given as u. Yes, bullet. If I assume the bullet moving positive x direction, and the gun will move which direction? Negative x direction. So mass of the gun is how much now? Capital M. And velocity of the gun will move backward direction now. Yes, so that's why, yeah, we'll write the V will write right now here. So then that should be equal to what? Tell me now simply. Finally, V is equal to what? Tell me now. Mu by capital M. This is minus now. This minus sign indicate that velocity of the gun is backward. This is the recoil velocity. Then next, a body of mass m and initially at rest and breaks into three pieces whose masses in the ratio 1 is to 1 is to 2. The particles having same mass fly off in mutually perpendicular directions of velocity v only. Both velocities equal. Find the magnitude of velocity of the third particle. Okay. Now you tell me now. Initially, I have one body. What they're saying here, we have one body is there, this body, and the mass of this body is m. Initially, this body is at rest. Initially, this body is at rest. So then, what is the initial momentum? Yes, so initial momentum of this body, which will be equal to what we can say now, 0, isn't it? And thereafter, what happened? Thereafter, what happens now here? This body and split into three particles. And the masses, how the ratio of the masses is given now here? So that is M1 is to M2 is to M3, and which is given as what? Tell me now. 1 is to 1 is to 2 given mass of the each particle. So tell me now how much is M1 now? We'll find this is sum of all masses. We can apply the ratio proportion native, we can apply, which will be M1 ratio is how much now? 1. So that is 1 by what we can say now? 4 into total mass is M na? M by 4 first particle mass. And if I say this first particle velocity is how much now? That is V. This same mass means 1 is to 1 will have same masses now. Now, so yeah, tell me now this second particle mass is, that is also 1 by 4 into m only na? And third particle mass is how much now? Yes, 2 by 4 into m. Right. So then this m1 and m2 will have a same mass. Same mass will have a same velocity, they are saying na? This velocity is also v. But how they are saying here? They fly off in mutually perpendicular direction. These two are perpendicular to each other. So if I say this is along the positive x direction is going, and then this should be along the y direction na? And but we don't know the velocity of a third particle. Third particle velocity we need to get. Understood the problem now? Now we apply the law of conservation of linear momentum. Since there is no external force is acting, the body is break into itself only. Yeah, so tell me now the law of conservation of linear momentum. Right. Total initial momentum equal to total final momentum, we can say na. Pi is equal to Pf. Initial momentum equal to final momentum. So tell me initial momentum is how much? Total initial momentum of the system. Total initial momentum of system is P1. Initial momentum is 0. And final momentum. So that will be given as M1 into V1 plus M2 into V2 plus M3 into V3. So this is 0 equal to M1 is how much now? M by 4. Okay, so V1 means V into I cap. Next one, M by 4 V into J cap, and next one is M by 2 into V3 value we don't know, we have to calculate. So now tell me now, all M will get cancelled now, and so V3 value will come to be how much now? That is minus V by 2 into I minus V by 2 into J cap na. And so that means what is the velocity of a third particle now? Tell me now this magnitude to be taken now. That is square root of what? Tell me now. V squared by 4 plus V squared by 4. So how much is V3 velocity? So that is equal to, yes, that is V by root 2 na? No, yeah. 2 V squared by 4. 1 2 will get cancelled. So that is V by root 2. This is the velocity of a third particle. Next one. And have you seen the Newton's cradle? So that when cradle is there now, so the 5 balls are there. So when one ball is released, only one ball will move. So here 2 balls are released. The 2 balls will move. The momentum will be transferred. Momentum. Newton's cradle. Yes, if I release the one ball, the one ball will hit the other one. Only one ball will move. Is there? Bring it. Burn out. Oh, sorry, they outside. If we throw one ball from go to same height and wow, the only one ball. The 5 balls are there. Okay, that image. That is an example. That is example of law of conservation of momentum. Newton's cradle we used to call. Newton. These things. Okay. Fine. Take the next one. No. That's nice. Mm. So it's a damage, Okay, so I also have this thing. My son played with this thing. He kharab. Yeah, pura kharab kiya. So this and here this is the string, but those are the wires. Wires. Those are mixed like anything. It is not able to separate us. So when we release now here, it will keep this thing. Ah, go ahead. Yeah. Right. And the next one. Yeah, you have this idea now. What is that? So that is the example. So this is the example of law of conservation of linear momentum. Right. What? Yeah. Do next one. Next problem. Take it. Hmm. Tell me. A body. of mass m projected into air with a velocity u, making an angle theta with the horizontal. At the highest point, it explodes in two pieces of equal mass. One retraces its path to the point of projection. Find the velocity of other particle. So means what happened now? They are saying your projectiles so actually this has to move like this. But when the body reaches at the highest point, after reaching highest point, it breaks into two particles. It breaks into two particles of equal mass. Now here, this particle and it is one particle moves like this. Equal mass. So let us say this mass is m by 2 and this mass is also m by 2, right? And one particle retraces its path to where? Point of projection only. That means this particle is reached again to here. Okay. Then they ask him to find what will be this velocity. Okay. Now you tell me now here. So when the particle is at the highest point, this at the point it breaks. At that location, do the particle will have a velocity or not? At the highest point, it has a velocity is there or not? We have a horizontal velocity is there. We have a u cos theta, u sin theta is there now. At the highest point, what velocity is present? U cos theta is present. Okay. Now tell me now here. So initial momentum. So this is law of conservation of linear momentum. Now tell me now what is the initial momentum now here P1 if I call total initial momentum is how much? Yes, mass. At the highest point, what is the velocity? That is u cos theta. At the highest point, the particle will have only a u cos theta only na. And so this is the initial velocity. Next, so final velocity is what you tell me now? So here velocity of this particle plus velocity of this particle. And velocity of this particle is how much we can say now here? So here this particle also u cos theta only na? Yes, this particle also u cos theta only, isn't it? Horizontal they will move. Okay, highest point the particle is at a rest only na horizontally. So u cos theta, but they will move opposite direction. One will move positive x direction, other will move negative x direction. So means what I can say now here after collision. So this means mass is how much now? M by 2. If this particle will move, what tell me now with a velocity u cos negative u cos theta, isn't it? Plus what tell me now? Yes, this particle, this is m by 2 into what tell me now? This is v2. This velocity we don't know. This velocity we don't know. So that velocity we need to get now. This velocity v2. We need to get it now. Okay, so now apply the law of conservation of linear momentum, that is P1 total initial momentum equal to total final momentum now. So that's why which will be given as what will be mu into cos theta and which will be equal to minus m by 2 u cos theta plus what will be now m by 2 into v2. Okay, simplify, get the value of v2. So how much is value? V2 value how much now here? 3u cos theta. This is the velocity. Okay.